Imagine staring into the depths of space and seeing something impossible. A black hole that, instead of swallowing light, reflects it back. That's not just poetic imagination or science fiction. It's a discovery that defies everything we thought we knew about these cosmic monsters. A place from which nothing, not even light, was supposed to escape, now behaving like a mirror at the edge of reality. Just recently, astronomers caught a black hole doing exactly that. It wasn't a glitch or a trick of the telescope. It was real. And it's rewriting the rules of how black holes work, and maybe, just maybe, how we understand the fabric of the universe itself. This strange reflection isn't just light bouncing off dust or gas, it's coming from the very edge of the black hole, where space and time stretch to their limits. Something is echoing there, and it carries information we've never seen before. Could it be a clue to the physics beyond Einstein? Or a sign that these dark giants are more transparent than we ever imagined? In this video, we'll explore how this black hole managed to reflect light, what it means for our understanding of space-time, the shocking theory of black hole echoes, and why this could be the first glimpse of quantum gravity at work. The black hole at the center of this astonishing discovery lies in a galaxy nearly 800 million light-years away from Earth, deep in the constellation of I-Zwicky 1. It's a supermassive black hole, the kind that anchors entire galaxies, millions of times more massive than our Sun. These giants have always been seen as the ultimate endpoints of light and matter, devouring everything that dares to come too close. For decades, astronomers believed that once something crossed the event horizon, the boundary around a black hole, nothing could ever escape, not even light. But in recent years, something strange began to emerge from the shadows. In 2021, researchers using NASA's NuSTAR Space Telescope were observing the black hole's corona, the superheated region of electrons that glows with intense X-rays. As they studied a burst of X-ray light from this region, they noticed something no one had seen before: faint X-ray flashes that seemed to come from behind the black hole. According to everything we thought we knew, that shouldn't be possible. Yet there it was, light echoing from a place where it should have vanished forever. It was as if the black hole had bent the very rules of reality. This was more than a glitch or anomaly. It marked the first time in history that scientists had directly observed light being bent and reflected from behind a black hole. Not metaphorically, not artistically, but literally. Light curving around the immense gravitational pull and making its way back to us. And in that moment, something deep about the nature of black holes and the universe itself shifted. 2. Understand how a black hole can reflect light, we first need to talk about the warping of space and time. According to Einstein's theory of general relativity, a black hole is not just a superdense object. It's a tear in the fabric of space itself. Its gravity is so intense that it bends everything around it, including light. Normally, when light passes near a massive object like a black hole, it gets bent slightly, a phenomenon known as gravitational lensing. But in this case, something far more dramatic happened. What astronomers saw wasn't just light being deflected, it was a true echo. Here's how it works. As material swirls around the black hole in what's called an accretion disk, it heats up to millions of degrees, producing X-rays. Above this disk sits a mysterious region called the corona, an energetic cloud of electrons that glows intensely and occasionally flares. In the I-Zwicky 1 black hole, a flare from the corona sent out a burst of X-rays. Some of those rays hit the accretion disk and bounced off. But incredibly, some rays also took a much stranger path, wrapping around the black hole itself. Due to the extreme warping of space, those photons curved around the back of the black hole, like a ball rolling along a stretched rubber sheet. And somehow they escaped, reaching our telescopes on Earth. The light we saw wasn't from the front but from behind. NASA's NuSTAR and ESA's XMM Newton telescopes captured this light, allowing researchers to observe what they call a light echo, a fingerprint of the distorted space around the event horizon. This kind of observation has never been done before. It's the first real evidence that black holes can act as gravitational mirrors, bending light in such an extreme way that we're able to see what's effectively their far side. This breakthrough supports Einstein's predictions, but also opens the door to new physics, especially as we try to unify quantum mechanics with gravity. If light can echo off a black hole, what else might be hiding in those echoes? Could it be a clue to the quantum structure of space itself? This isn't just a fascinating effect, it might be a glimpse into the deepest workings of the universe. Here's where things get even more mind-bending. The black hole we're seeing in IceWiki 1 is 800 million light-years away, which means everything we observe actually happened 800 million years ago. When the X-rays bent around the black hole and reached Earth, they carried with them a snapshot of a time when dinosaurs were still roaming our planet. So, in a sense, we're not just looking across space, we're looking back in time. Because of this, the strange light reflections we're seeing now may be just the beginning of a much larger cosmic event that's already long past. We might be witnessing early signs of extreme instability around the black hole, such as chaotic flares, sudden accretion disk disruptions, or even the merging of black holes, something that could send gravitational waves rippling across the universe. While these events may have already unfolded in real time, their light and radiation are only now reaching us. That's the mysterious rhythm of astronomy. Everything we see is history unfolding in slow motion. If such an explosive event did occur, say, a merger or a violent burst of energy, it could appear in our skies as a spectacular flash, maybe even bright enough to outshine a full moon. Though not visible with the naked eye due to its distance and X-ray spectrum, observatories like NuSTAR, Chandra, and even gravitational wave detectors like LIGO would catch it. And if we're lucky, that light show might still be on its way to us, traveling across the darkness like a cosmic telegram, waiting to arrive at just the right moment. Imagine stepping outside on a clear night and seeing a sudden, piercing glow in the sky, something so bright it outshines every star, every planet, even the full moon. At first, it might look like a new star has appeared out of nowhere, but it wouldn't twinkle, it would blaze, a white hot point hanging silently above us, visible even in broad daylight. If a major event, like a black hole merger or a catastrophic energy release, were to happen in IceWiki 1, the resulting light show would be unlike anything humanity has ever witnessed. For weeks, maybe even months, that glow could dominate our skies. Telescopes would catch the sharp rise in high-energy radiation. Space observatories would scan every detail, while news outlets across the globe would buzz with theories and explanations. And for the first time, billions of people might all be looking up, united by a shared moment of cosmic wonder. Of course, we wouldn't be in danger. At 800 million light-years away, the distance keeps us safe. But the emotional impact would be profound. We'd be witnessing the final death throes of something unimaginably massive, long gone yet only just arriving in our skies. A cosmic echo from a forgotten time, flashing above our heads. And in that moment, we'd remember just how vast and mysterious the universe really is. Not as silent or distant as we often think, but alive, dramatic, and always reaching out to us through light. This discovery isn't just a dazzling light show. It's a goldmine for science, both literally and figuratively. Events like black hole flares and mergers don't just warp space and time, they're responsible for forging the heavy elements that make up everything we know. When black holes collide, or when neutron stars collapse into them, the resulting explosions, called kilonovae, are so powerful they create elements like gold, platinum, and uranium. These aren't formed in ordinary stars. They require the immense pressures and energy unleashed only during the universe's most extreme moments. The very fact that we can detect echoes of light bending around a black hole means we're now able to study these moments with more clarity than ever before. It's like opening a window into the engine room of the cosmos. Scientists can analyze the light, measure the energy, and decode what materials are present. It's in those signals that we find clues to how galaxies evolve, how elements are distributed, and ultimately, how life itself becomes possible. Because the truth is, every atom in our body, carbon, oxygen, iron, was born in stars like these. Some were forged in supernovae, others in ancient colonovae, billions of years ago. We are quite literally made of the universe's most dramatic endings. From stars like Antares to the Titanic VY Canis Majoris, all the way to the black hole in IceWiki 1, the cosmos is constantly recycling matter through destruction and creation. Understanding how light behaves around a black hole isn't just a scientific breakthrough, it's a spiritual one. It reminds us that we are part of this cosmic story, not separate from it. Despite how dramatic all of this sounds, there's no need to worry. Earth is perfectly safe. The black hole in IceWiki 1 is nearly 1 billion light-years away, far beyond the reach of any harmful radiation or energetic wave it might release. Even if a massive flare or explosion occurred, by the time that energy reaches us, it would be incredibly diffused. We might detect fascinating signals, like a spike in X-rays or neutrinos, but not enough to pose any threat. In fact, some of the effects might even be beautiful. Depending on the nature of the outburst, we could see changes in auroral activity, or minor shifts in the ionosphere, similar to what happens during strong solar storms. These would be harmless, just subtle reminders that the universe is alive and in motion. Thanks to advanced neutrino detectors like Super Kamiokande and IceCube, scientists could even receive a silent, invisible signal hours before the visible light arrives. These ghostly particles travel ahead of the main flash and could trigger a global alert system, giving astronomers a rare chance to ready their instruments. It's like getting a cosmic heads-up before the curtain rises on the universe's greatest show. We're witnessing the final breath of a giant, a farewell millions of years in the making. The light that bends around that distant black hole isn't just a flare of radiation. It's a whisper from the deep past, a message encoded in photons, traveling across the cosmic sea to reach us now. In that light is the story of matter falling into darkness, of stars dying and transforming, of space itself curving and echoing in strange and beautiful ways. Moments like this remind us how small we are, but also how connected. A black hole, 800 million light-years away, can still shape the thoughts we have tonight, still pull our attention upward, still ignite wonder in the heart of a human being spinning on a tiny planet. Time stretches unimaginably across the cosmos, and yet here we are, catching a glimpse of something ancient and extraordinary. We may never see the explosion with our own eyes, or we might, tomorrow, next year, in the lifetimes of our children. But one thing is certain: the universe is never still. It is always creating, destroying, evolving. And somewhere out there, just beyond the veil of darkness, another wonder waits to be seen. So keep looking up, because the sky is not the limit. It's just the beginning. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. We'd love to hear what you think about this incredible cosmic journey.